And we talked about, last time we met, we talked about a line plot, and we are going to, if you look at on page 319, they give you, what does it say? What are they? John Paul recorded the ages of the first 20 people who went down a certain water slide. Yay. Let's make our own little line plot of that, because we need to have this kind of for reference. Ages of people that go down the water slide, and it looks like it goes from 5 to 25. So let's see if we can do this as best we can. Whew. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Guess I could have had a lot more room there. Maybe I'll redo that. The beauty of the board, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And then putting the X's above them. Looks like we probably could just copy what they have there. Or should we just do it? 1, 8. Make my X's bigger too. This is not coming together as I hoped. 1, 8. 3 9s. 1, 2, 3. How many 11s? 3? Are you with me? Does everybody know where I'm looking at? Okay, good. 5 12s. 1, 2, 3, 4, 5. 3 13s. A 15, a 16, and a 17. And a 21 and a 22. What is a 22-year-old doing going down those slides? That's the question you should ask yourself. Sorry, I gotta do this because I'm off a little bit here. Today will be a good thing you've got your notes because there's going to be some things you probably haven't talked a whole lot about before. We did mention this before here. When you have a line plot or other data, sometimes you look for what we call clusters. And right here, that would be a cluster, because it's just like it sounds. What is a cluster? A cluster of grapes is where you see a big grouping of them. And this would be a cluster. Obviously, people at the water park look like they're probably going to be 9, 11, 12, and 13 years old, which makes sense. It's been a while since I've been to the water park, but that's probably a good deal, right? I mean, especially you don't have little 5-year-olds going down the big water slides because they're kind of scared. But then we also have these things over here. If there are like a couple data things that are like really kind of away from everything, we call these two things outliers. Because they're, I don't want to say abnormal, they just don't fit with the rest of it. They're kind of really far away from the graph. And a lot of times when you have outliers in data, you kind of throw those away. You know, just because they kind of mess things up. So if you see an outlier, you can kind of disregard it. And then the things we need to talk about are these. We have, in data, we have something called the mode. Did you talk about modes last year? Mode, I like to remember, because what it really is it's the number that appears the most. So if you look at the first two letters of both of them, the mode and the most, if you're looking at this set of data, what number appears the most? Well, that's the one that has the highest number of x's. So the mode in this one is 11, 12. The mode in this data is the number 12 because there's 5 of them. Okay, 5 12, so we call that the most. And then we have something that's called the median. And maybe you've heard of a median before when you're driving down the road. What's the median? Bolt?
The median is a thing that
that would be a radar. Median, Frankie, what's the median?
I'm guessing it's something that keeps you in the middle.
There you go. Median means the middle. You know, especially, you know, on an expressway, you've got the two lanes going one way usually, and then the two lanes going the other way. And that little grassy area that separates the two is called the median. Why is it good to have a median? Because if somebody went off the road, you wouldn't want them coming directly into you. They'd have to go through a bunch of grass and whatever, and it wouldn't wake them up anyways. So just like that, the median here is the middle number. Now, how in the world would I find the middle number? Well, first thing, to find the middle, you have to know how many numbers you have. How many numbers? If I look at all these numbers here, how many, if I added them all together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I have 20 numbers, okay? And they have to be lined up in a row. If you had 20 numbers, what is the middle of 20? And which one would you have the same amount below and the same amount above, Colin?
10.
10. So what you can do is this. These are your low numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you stopped right here, you'd have 10 numbers that are lower than this, and you also have 10 numbers that are higher than that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median in this is also 12. The median in that would also be 12. We could also do that with, wait, how many people are in the class right now?
22. Yeah.
22.
21. Yeah, because 22 in this class.
Yeah, we won't worry about that there. And then the last thing we're going to talk about when it talks to this data stuff is the range. The range is what you get when you subtract the big from the small, or the small from the big. The smallest number from the biggest number. In this case, my biggest number here is 22. And then I take away from it, what was that, 8? Take away 8, which is my smallest number. My range is 14. You know, which makes sense because the ages range from 8 years old to 22 years old, which is 14 years of range. So make sure you know what range, median, and mode is. I don't think we talked about median, do they? No. Got that? Now, do me a favor, take a look at page 321, if you will. Let's put this into practice. See if we can't figure out what that line plot there. Starting at the bottom of page 320, it says the Lizard Emporium. I've not ever been to the Lizard Emporium. Tracks the lifespan of an iguana. Does anybody have an iguana? Have you ever had an iguana? Anybody want an iguana? Anyways, it says the data obtained for 21 iguanas are displayed on the line plot on the next page. So looking at that line plot, it looks like one poor iguana only lived 10 years, while the oldest one looks like it lived how many years? It's like 28. Alright, let's see if we can answer some questions there. What was the most frequent lifespan of the iguanas that were tracked, which is also the mode? What number in the lifespan of an iguana, what was the number that appeared the most? Which one has the most X's above it, Julia?
19.
Yep, 19 years. How many iguanas were tracked altogether? Which means you may have to actually count how many X's are there. Victoria?
21.
21, look at that. We're 2 for 2. How many iguanas live between 17 and 25 years? How many iguanas live between 17 and 25 years? Tyler, what's your thoughts? How many? You may have to actually look. How many iguanas live between 17 and 25 years? Wait, are you looking at the same? You're looking at the right page? Are you on page 321? At the top, how many iguanas were there between 17 and 25? We are getting there. 15, congratulations. How about what's the range of iguanas' lifespans? Smallest from the biggest, Brian?
18 years.
18 years. Now here's the tough one. What would be the median lifespan? The middle. We know there's 21. What is the middle of 21? If you have 21 numbers, Andrew, what's the middle of 21?
11 and a half.
No. Technically, I mean, that's a good thought right there. The 11th one is exactly in the middle. Why? Because there are 10 below and there's 10 above. That 10 plus that 10 is 20. The 11th one is the 21st one. Okay, so if there's an odd number, there's exactly one in the middle. This one here, notice how our middle fell between two numbers, but they were both the same number, so it didn't matter. This one, whatever number 11 is the exact median, which would be, Jacob Bowman.
11.
Yeah, but how old is that one that's 11? You have to count 11 over from the left or 11 back from the right. Which one? How many years old would that one be? You know what I'm saying? On your graph there, Jacob, you have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and find that 11x from the left, which would be how many years old? 19. Bam. You got it there. What you got there? Now skip down ahead, down to the bottom there. This thing here, where it says the pictograph, and then let's write down a pictograph. What do you suppose a pictograph is? Just like it sounds, it's a graph that uses symbols or pictures. And the important thing to realize with a pictograph is what does each symbol stand for. And if you look at our pictograph there, you've got all those little plates. What does each plate stand for? Does it stand for just one dinner? If you look at page 322, every plate stands for, Allie? 10 dinners. So if they show a half a plate, how many dinners would half a plate be? 5 dinners. If they showed a quarter of a plate, who knows? 2 1/4. So the question they have is, how many dinners were served on the day that the most dinners were served? How many dinners were served on the day the most dinners were served? Which one has the most plates after it? Addie?
Friday.
And how many dinners is that?
9.
It's not 9, and that's why you need to know every plate stands for 10. So it's not 9 dinners, but 90 dinners. There you go. And then letter B says, what is the mode of the data displays dinners served? What is the mode? What number appears the most on those? If Tuesday is 40, Wednesday is 40, Thursday is 50, Friday is 90, Saturday it looks like it's 70, Sunday is 40. Which number appears the most, Frankie? 40 dinners. And then look at the bar graph down there. You should be pretty good at reading bar graphs, are you not?
Yeah.
Question number 18 says, what is the total number of students represented by the 4 bars in the graph? What total number of students would that be? Well, that's kind of a tough question. It's like 9, 6, 5, and 8. To do a little math at some point. Victoria says
28 students.
28. Is it true that the number of students who name pizza as their favorite had twice the number of those who name spaghetti? Is pizza twice spaghetti?
No.
No, because twice spaghetti would be
10.
5 native and twice that would be 10. Holy smokes. We might just call that a day that we look at here. Now take out your blank piece of paper and write multiplication on it. And today we're just going to, because this is not very hard, we're going to talk multiplying by a 2-digit number. I might do this again because for some reason I seem to keep. For example, let's say we have 43 times 12. First time we run across this. Now, something to think about in this. Well, maybe not. Yes, maybe. Well, let's just do this here. How do we do multiplication by double-digit numbers? What is the algorithm for this? Just out of curiosity. Colton, when you multiply double-digit numbers times themselves, what's the algorithm? First step is to do what? So after we write the problem down, that's good. That is the first step. First step is, Brian, to
Multiply the digits in the ones place.
yeah, multiply by the ones digit. Multiply the top by the ones place. So let's do that. So I'm going to take, this is the ones place. So this 2, I'm going to multiply it by that. 2 times 3 is 6. 2 times 4 is 8. Boom, boom. Now here's where things get a little dicey. Step number 2. Step number 2. What do you do next? Here's where most people go wrong. George Shaw.
Go to the tens and multiply one of the numbers from the ones.
Right, but before you do that, in order to keep your life simplified, Jordan,
you add the number that.
we're getting there. Frankie?
Okay, so in the tens place you multiply that, and then put the 0, that number, add it, and
Well, your first step should be to put a 0 down to start. And we're going to talk about that just for a second. In other words, your next step is you need to put a 0 down here, right? Anybody know why we do that? Why do we do that? Brian?
because you're multiplying the tens, and so there's going to be no number in the ones.
Right. In other words, this, and this is what Brian said. Take a look up here because the book makes a point of this. Really, when we do our multiplication problems, 5th graders, Maryland, when we do our multiplication problems, especially these long ones, you are doing like a shortcut version of it when you do it. Really, if you're going to do it the long way, you would take 43 and multiply it by 2, get your answer, And then to that you add 43 multiplied by a 10. Because that's what we're doing. When we move across to this, when we go across to here, we multiply by the 1s. 43 times 2 is 86, but now I'm multiplying that by a 1 because that's in the tens place. And what happens every time we multiply by 10? Remember, we always hung out that 0 and brought it straight down? Well, that's what we're doing here. We're bringing that 0 straight down. Then we're multiplying through by the 1. 1 times 3 is 3, and 1 times 4 is 4. And then as your last step, after you multiply by the tens, digit, and your last step then is to add your columns together. And then you end up with 615, 516. And here's another time to stop and say, if you don't know your multiplication facts, this is going to be a little bit tougher for you. You ready for one more thing? Well, let's do one more. I'm going to give you a chance to do one. How about this? 52 times 32. I'll let you do that one. 52 times 32. I think it still isn't calibrated very well. Do that for me for a second there. 52 times 32. Answers we have? Yes? No? Trevor, what'd you get?
1,664.
Well, let's see. So you multiply through by the 2 first, right?
Yeah.
You got 4, 2 times 5 is 10. Everybody got that for the first row?
Yeah.
And don't forget, when you get to the tens place, you have to start with the 0. 3 times 2 is 6. 3 times 5 is 15. Those are my rows I add together, and I got 4, 6, 6, 1. Good with that? Now I need to take out one more blank piece of paper. That's what happens when we got distracted last time.
Last time we got distracted, so we didn't have
And right on top of it, the distributive property. Got that down? Okay, here's the deal with this. And it kind of ties into what we're doing, but you may not see it right now, but sometime, maybe not till you're 35 or 36, this, like a light bulb will turn on, you'll go, that's what Mr. House talked about when we were back in 5th grade. Here you go. If you see this, 25 times 10 plus 2. You got this problem here? You got that? It is very easy, but here's what the book wants you to understand here. There are 2 ways to do this problem. Number 1 way is to do what we did for today and add 10 plus 2. What is 25 times, what is 10 plus 2? 12. And I do 25 times 12. Let's just kind of do that together. Sorry, it should be times. 2 times 25 is 50. What do I do next? Put the 0 down, right? 1 times 25 is 25. So my answer is what, ladies and gentlemen?
300.
300, right? This is what we did for today. Now, when you're 35, this will all make complete sense. The other way to do it is to do it by the distributive property. And if you think about it, does anybody know what the word distribute means? It's kind of the way I remember distribute. Distribute means to do what, Nathan?
Sort of like give like something like kind of giving it.
Yeah. Like, you know, usually at the end of class I distribute a quiz. If you think about me handing out the quiz or distributing the quiz, what do? I go, well, sometimes I throw them at you or just drop 3, but distribute means I give you one, I give you one, kind of like go 1 to 1. The distributive property says this. If you see a parenthesis, you can, instead of adding these two numbers together right away, you can distribute out the 25 and multiply the 25 by the 10, and then distribute it to the second number and multiply it by that number, and you'll still get the same answer. Okay? Distribute it out, kind of like you hand out the 25 to the 10 and hand it out to 2. We should still get 300, right? Well, 25 times 10, pretty simple, is 250, right? 25 times 2 is 50, and when you take 250 and add 50 to it, you get 300. Now, what might come in handy for you to remember on this is people that do big multiplication problems in their head, they do it like this, using the distributive property, because it's much easier to do in your head using this than it is to do it like this. Okay? It is much easier. But for now, you just need to know that when it tells you to use the distributive property, you always have to have parentheses, and you always can take that number and multiply it by 1, and multiply it by the other, and distribute it out. Oh boy. So here's an example right out of the book. Let me see if I can find it here. If you have the book will say to do this, use the distributive property, it'll say show 2 choices for multiplying what is it? 35 times 20 plus 4. And if you go back and think about what we just talked about, let me give you a little reminder. Remember the 2 choices? One choice was to do it like this, add the parenthesis first and multiply. The second one was to use the distributive property and write it out like that. If I use that same concept here, my first choice I can do is multiply 35 times what? Add those together, you get, there's choice number 1. By the way, I'm not going to make you do it. Choice number 2 would be to do what? Doing the distributive property, you would, Colin, take
35 times 20.
And to that you would add
35 times 4.
Times 4. And again, when you get good at multiplying, you'll be able to do this in your head because, well, 35 times 20 is 700, and 35 times 4 is 140. 840 is the answer to that just by doing it in your head. Is that true if I do this? I'll take my word for it. It will be true. What time is this class over?
10.
Perfect. All right, we're going to stop right there. No assignment.